Welcome to my class, my dear students. In today's lecture, I am going to do the most important and interesting, and of course, many students will be getting so much of confusion on conditional probability. About this concept today, I am going to do. Not only the students, many of the teachers, even I used to face lot of confusion when I was doing this conditional probability, total probability and Bayes theorem. These are the three important concepts wherever you go in science or in any project or in any whatever the event, suppose in the data science also, the major concept, the backbone of data science is conditional probability, I can say. So now coming to this topics, how to understand these concepts of conditional probability. I have before going to the definition, I just wanted to explain you by small example. Suppose let us see that there is a house and the entrance is from this side. As soon as you enter into the hall, there are two fridges here, fridge 1 and fridge 2. And the fridge 1 consists of 3 cool drinks and 5 juices, let us say. Fridge 2 consists of 6 cool drinks and 7 juices, let us say. So totally there are 8 products here in fridge 1 and there are 13 products in fridge 2. Okay, let us come to the concept here. Now, in the problems, so we always think about how the problems will be given and what is that, whether it is conditional or Bayes theorem or total probability. These are all you want to find out, suppose. So, for identifying the difference, just I am giving you this example. Let us make an attempt to understand this. Now, I wanted, suppose in the problem it is given that the fridges both F1 and F2 are being selected randomly is given. The word random is used, suppose. Then we can say that there is a chance of 50% of opening F1, 50% chances are there for F2. Suppose it is not given, randomly is not given, they have given the probability. By thinking that the people are coming from the hot sun and as soon as they enter, immediately the first one which is near to the entrance is fridge 1. So opening the fridge 1 probability is more, let us say 75% of opening fridge 1 is there, suppose. And 25% is there to open the fridge 2, suppose. Then F2 is 1 by 4, like this, suppose given it is, okay. If they have given randomly means 50-50 chances you have to take. If no, they have not given, they will give like this. The probability of F1 is so much, probability of F2 is so much, they will give you. Now, let us come to the normal probability which we have done in the previous classes, the selection and how it is now. Suppose I wanted one cool drink from fridge 1. That is my normal question. One cool drink from fridge 1 means one cool drink from fridge 1. I have in fridge 1 totally 8 products. Out of 8, I wanted one item which is the cool drink, which can be done by 8C1 is the denominator. And what is my favorable event? The numerator is what? There are 3 cool drinks specifically. So out of 3 I wanted 1. So this 3C1 which is 3 by 8, let us say. I hope this is clear. Similarly, I wanted one cool drink from fridge 2 is normal question asked, suppose. Then what it is, out of 6 cool drinks, my favorable event is out of 6 cool drinks, 1 cool drink I need. So 6C1 over the total number is 13C1, which is this one. This is the normal simple probability. Now, let us come to one question, one sentence that, try to understand the sentence. Somebody has been given a condition for you that you select, I have already selected fridge 1. Now, you select the cool drink from fridge 1. Because there is an order, there is a condition here that I have already selected fridge 1. Now, you select the cool drink from fridge 1 is the question, suppose. That means what? The probability of the cool drink which has given that the fridge 1 is selected. So, that means there are 2 events here happened. One is the selection of fridge 1. The other is the selection of the cool drink in fridge 1. So, which is first happened? F1 is happened first. So, selection of fridge 1 is happened first. And then you are selecting the cool drink. So, this is what the notation we use, that probability of cool drink selected given that F1 is selected. Now, this is called as the conditional probability. This condition is been given. That is a formula P of C given F1 is given by P of Now you are selecting both F1 and C, right? So it is C int. I used the word and, remember. I have selected F1 and C intersection F1 over the probability of F1 because F1 is been already selected. Okay. So this is about your conditional probability. Now the sentence is, you have somebody has given you a cool drink. Now you are asked to find out whether I wanted the probability of the cool drink. That's it. You are not bothered about whether it is from fridge 1 or fridge 2. You are not bothered about that. Only you wanted the probability of the cool drink. Then what you say? What is the probability of that cool drink? Then you have to consider these two. No, either it should happen in this fridge 1 or it should happen in fridge 2. Correct? Now, so when I say or, please listen to the sentence what I am using. Listen to the words of what I am using. So when I say or, that means the probability of the cool drink, one cool drink I wanted. What is that? Either it is from fridge 1 or it is from fridge 2. Now if it is from fridge 1, then what is the probability? P of the cool drink selected from fridge 1 multiplied by its probability of fridge 1 plus probability of the cool drink over, given that it is from F2, and into multiplied by probability of F2. Now what we are doing? Probability of this F1 and probability of F2, these two we are totaling. So it is the total probability. Now for example, you have another fridge also. Fridge 3 is also there, and there also some drinks and juices are there, suppose. Then what it will be? P of C given F3 multiplied by P of F3 will be added. So that is called as the total probability. Total probability we say. So the probability of cool drink only you need. We are not bothered about either it is from fridge 1 or fridge 2 or fridge 3. Remember, I am using either fridge 1 or fridge 2 or fridge 3. So this is what the total probability. Now let us come to the Bayes theorem concept. Where it is now again you have got that cool drink. Now tell me what is the probability of that cool drink it has been. What is the probability that it has been taken from fridge 2? Suppose that is the question. That means the reverse way. Now what is in the conditional probability, what it was? Selection of the cool drink, selected that already fridge 1 is selected. Now in the Bayes theorem, what is inside the container? That is what already given. Cool drink, you got it. You have already selected the cool. Somebody has selected the cool drink already. Now you tell me what is the probability of this cool drink which is being selected from fridge 2. That is what asked, suppose. Then this is the Bayes theorem. How is it now? That is probability of the cool drink which was selected. Tell me what is the probability of that from? It is from fridge 2. Then that is what the Bayes theorem. Now how to use this? What is the definition? How to remember this? P of F2 by C. Take the reverse of it. P of C given F2 multiplied by P of F2 over the total probabilities. You know the classic definition of probability. Sum of the total probabilities is the reminder. What is your favorable event? It should be from fridge 2. So P of C given F2 multiplied by P of F2 by C given F1 multiplied by P of F1 plus P of C given F2 multiplied by P of F2. What is this? This is the total probability. So this is Bayes theorem. This is conditional probability. This is total probability. Normal simple probability is this. I hope you could understand. But when you do the problems only, you will understand more easily. So let us now start the problem here. A die is thrown. Find the probability of getting number 4. Given that an even number already has been occurred. So here what is that? We know the die is already, the die is rolled on, and then the even number has already been occurred. So what is the probability of getting 4? That is what the question. So A is given as suppose 4 and B is the even number already happened. Then what is P of A given B is given by P of A intersection B by P of B. What is P of A intersection B? How to find out this? For this, what is A? A is an event of occurrence of 4. Correct? A is 4. B is an event of even number. Even number means what? 2, 4, 6. These are the even numbers when you roll a die. Okay. And then what is A intersection B? We have done in set theory concept. What is the common portion? I hope you could understand that. Our A is A and B are this. Now there are the elements. This is A and this is B. And in A you have 4 and in B you have 2, 4 and 6. So now can I say that A intersection B is having 4? Yes, no? A is having only 4. B is having 2, 4, 6. So A intersection B is, the intersection portion is 4. So it is clear now. So now let us have this as S is given by 1, 2. So the sample space is this, and probability of A given B is given by, what is the formula here? It is given by n of the number of elements in A intersection B by the number of elements in n of S. That is 1 over. N of A intersection B is what? 1. Only one element by number of elements in the sample space is X. So what is P of B is n of B by S, which is 3 by 6, and hence we get the answer. P of A by A intersection B is 1 over 6. P of B is 3 over 6, which gives you 1 by 3. Now let us understand one more interesting problem. Try to understand this problem now. Let us see here. Now let us see the probability of that a civil work will be completed on time or there is rain is 21 by 30. So there are two events here. One is civil work completion, the completion of the work. Completion, let us see, C is the completion of the work. Okay, and let us have R means it is rain. Now try to understand the word terminology here. The probability that a civil work will be completed on time or there is rain is this. So what do you mean by R here? R means union. You will understand that, right? So P of C union R, either the civil work is completed or there is rain, the probability is given as 21 by 30. Next, the probability that there will be rain and the civil work will be completed on time is 6 by 15. So what do you mean by here and the civil work? And means what? Intersection. You should understand that. So that gives you what now? P of civil work completed intersection the rain is given by how much? 6 over 15. This is what given. What next? The probability that the work will be completed on time given that there is rain 6 by 9. So that means what was the event first happened? The rain is already happened, given that the rain is already happened. That is 6 by 9. So what is it now? Let us see. P of rain given that there is rain. That means given that R and civil work is completed. And this is given by 6 by 9. Okay. Now what is the probability that there is no rain is the first question. What is the probability that there is no rain? What do you mean by no rain? Rain means R. No rain means R bar. Correct? Complement of R. So what is the probability of R bar is the question. What is the probability of R bar? 1 minus P of R. Now you don't know what is P of R from this, correct? But you know one thing. What is that? P of C given R. What is the conditional probability definition? P of C intersection R over P of R. This is the conditional probability definition. Conditional probability definition. Now what is P of C intersection R? 6 over 15. What is P of R? We don't know. We are going to find out that. And what is P of C given R is 6 by 9. So what is P of R now? P of R is given by 6 over 15 over 6 by 9. That means into 9 by 6. 6 gets cancelled. 9 by 15 means 3 3s and 3 5s. So P of R is 3 by 5. Therefore, what is P of R bar now? P of R bar is 1 minus P of R that is 1 minus 3 by 5, which is 2 by 5. So what's the first question answer? The probability of there is no rain is 2 by 5. Okay. Coming to the second question. What is the probability that the civil work will be completed on time? So what is the question asked? Completed on time. That means what is P of C? This is what was asked in the question. Now what are in handy with your problems to get P of C? You have to see that. You know P of C union R. You know P of C intersection R. You know now what is P of R. Now you need to find out P of C. Immediately you should get a flash that you have to use the addition theorem here. Correct? These are the contents you have. So if you know the theorems, it will be easy for you to remember, to do the problems. So P of C union R is what? P of C plus P of R minus P of C intersection R. Okay. Now, what is given conditions here? Whatever given, you write down. P of C union R is 21 by 30. P of C is, you don't know. P of R, you know that it is 3 by 5. P of C intersection R is 6 by 15. So, this is what you will get. Now, let us see what is the, how to solve this now. This is P of C is given by 21 by 30 minus 3 by 5 plus 6 by 15. When you do the calculation, you will get the answer as 1 by 2, which is 0.5. Okay. So, this is what your P of C. Now, let us come to the next one. What is the next question? If the civil work will be completed on time, what is the probability that there is rain? See, try to understand. Here it is the reverse. In this question here, it is given that there is rain, what is the probability of the civil work will be completed given that there is rain? That is what the conditional probability. If civil work will be completed on time, what is the probability that there is rain? So now what is that? What is the probability that there is rain? That means probability of already civil work is completed given that. What is the probability of the rain? So what is the formula for this? P of R intersection C over P of C. So this is what the result. What is P of R intersection C? We know 6 by 15. What is P of C? We know, which is 1 by 2. So it is 6 by 15 multiplied by 2, which is 12 by 15. And the answer of this is what actually? 12 by 15 means 0.8. So this is what the answer. This is P of C. Is that clear all of you? So P of R given C. That means the civil work is completed already. What is the probability of getting the rain now? That is what given by this one. I hope you could understand this. Now let us go to the next problem. Now this question. Bag 1 contains 2 red and 1 black ball. So now let us say bag 1 contains 2 red and 1 black ball. And bag 2 contains 3 red and 2 black balls. Okay. Now what is the probability that the ball drawn from one of the bag is red? So now as I told you that in my example, I want the cool drink. I am not bothered about whether it is from frizz 1 or frizz 2. Like that it is. What is the probability that the ball is drawn from one of the bag is red? I wanted a red ball. I don't know which bag it is. Understood? That is what the question here. So now what is that? First of all, what is the probability of the bag 1? Now he has not clearly told you what is the probabilities of bags. So what is the probability of bag 1? Randomly it is selected, we can say. Probability of B1 is half. Probability of B2 is also equal to half. That is what first we can identify. Now let us have the event that we wanted to select the red ball. The red ball means choosing the red ball. Given that, choose the red ball and let us have the red ball given that bag B1 is selected already, suppose. Then what is it? It is given by P of red ball from bag 1. How many red balls are there? 2 red balls out of 3 red balls, out of 3 balls, which is 3C1, which is 2 by 3. Because there is total 3 items here, there is totally 5 items here, correct? This is the total, this is the total. Now, I wanted the probability of red ball. Already bag 2 is been selected, R given B2. Now, what is that? 3C1 over 5C1. So, that means it is 3 by 5. That is also over. Now, I wanted the red ball. Now, I am not bothered about whether it is from bag 1 or it is from bag 2. As I told you, it is, if it is from bag 1, then it is R given B1 multiplied by the probability of B1 plus, if it is red ball is selected from B2, then multiplied by the probability of B2. So by this you should understand that it is the total probability. P of R given B1 is 2 by 3, P of B1 is 1 by 2 plus P of R given B2 is 3 by 5 and this is P of B2 is 1 by 2. So this is 1 by 3 plus 3 over 10. So what it gives you? It gives you 0.6333 and so on like this. So this is what the probability of the red ball. So what is this? This is the total probability. You can understand this. This is the total probability because in the question what was asked, what is the probability that the ball drawn from one of the bags is red? In the same question, suppose there is not asked, it's not asked, but if I ask you, let us see, if I ask like this, find the probability that the ball, the red ball drawn, find the probability that the red ball drawn was from bag 2. Find the probability that the red ball drawn was from bag 2. So what do you mean by that? Now coming to that the red ball drawn was from bag 2. That means what? Which is first happened now? The red ball was already selected. Now you wanted to find out the probability of the bag 2. That it is been selected from bag 2. What is meant by this? This is given by P of R given B2 multiplied by P of B2 over P of R given B1 multiplied by P of R given B2, sorry B1 multiplied by B of B1 multiplied by plus P of R given B2 multiplied by P of B2. This is the total probability. Okay. So now R given B2 what it is? We know that is 3 by 5. 3 by 5. P of B2 1 by 2 over, we have already done this, P of R, which is the total probability, which is 0.6333 and so on. So it is 3 by 10 multiplied by 1 over 0.633, something like this. So this is what the way to understand where you have to use the Bayes. This is Bayes theorem. Understood? If it is asked, what is only the red ball means either this or this means it is total probability. Or if you wanted to find out the probability of the drawn ball was red ball, find the probability that it is from B2. Okay, find the probability that the red ball drawn was from B2. So this is what the Bayes theorem. I hope you could understand the difference between total probability and the Bayes theorem. Let us now come to this problem. What is this problem? A shopkeeper sells 3 models of televisions A, B and C. So sale of the model A is 40% of which 3% are with stereo. So now what are the probabilities of A, B, C models are given. Now probability of A, the model A is 40%. 40% means you can say it as 0.4. Next, probability of B. What is the sale of model B is given that it is 40%. So again it is 0.4. Then probability of C. What is it? It is given as, probability of C is given as 20%. So that is 0.2. Now coming to the point here. Sale of model A of 40%, in of which 3% are with stereo. So what do you mean by that? The model A is with stereo is this much. So how to use that? That means what? It is the stereo, given that it is from the model A. What is that? What is given? Of which 3% are with stereo. So therefore it is 3%. 3% means 0.03. Next, probability of the stereo, given that it is from the model B, and that is given as 7%. So it is 0.07. Probability of the stereo with the model C. What is this? That is given by 0.09. Okay, these are given to you. Now the question is, what is the probability of which 9% are with stereo? What is the probability that a randomly sold television is with stereo? So what it is? I want the cool drink. I'm not bothered about it is from A or B or C. What is this? Total probability. Compare with that example, you will understand. So now, what is the probability of the randomly sold television is with stereo? That means I wanted what is the probability of the stereo. That means it is probability of the stereo by A, given A, multiplied by the probability of A, or probability of the stereo by the model B multiplied by probability of B, or probability of model S given C multiplied by probability of C. What is this? This is nothing but the total probability. I hope you could understand. Now, so what is 3%? Is 0.03 multiplied by 0.4, and this is 0.07 multiplied by 0.4, and this is 0.09 multiplied by 0.2. So when you do this all additions and all, you will get the value as 0.058. I hope you could understand with these examples. In the next video, in the next lecture, I am going to do some more examples to make you clear about the total probability, the Bayes theorem, and the conditional probability. Thank you so much for understanding. Keep in touch. Thank you.